And finally, we're going to talk about metamorphic rocks. So the scheme for metamorphic rock identification, you're looking for foliation. So over here we have non-foliated and foliated. So foliated is the banding or alignment of minerals. They look like little scratches on the mineral surface. And the composition you can see here, type of metamorphism, comments, rock names. Then the non-foliated type from fine to coarse texture, the different types of metamorphism, and then the individual rock names. So remember, you're going to need to know how to use that for your test. You will be given a reference sheet. You just have to know how to read that. The key ideas with metamorphic rocks. These are formed when existing rocks, such as igneous, sedimentary, or other metamorphic rocks, are changed by heat and or pressure. So we're talking about happening deep inside the earth here. The new rocks may resemble the parent rock in their mineral composition or color. The important thing is that the original rock cannot melt. If it melts, it becomes an igneous rock. It's no longer metamorphic. So it's the difference between leaving a pop bottle too close to the flame and it warps versus the pop bottle actually melting and becoming a puddle of melted plastic. Different types of metamorphism. There's regional metamorphism. These are large areas of rock that are changed by heat and pressure. And so the green areas, those green and yellow bands right there you can see, that's the region of structural deformation caused by metamorphism. Then there's contact metamorphism, when that liquid hot magma touches the layers of rock and the heat causes the rock layers to change. So that contact border that surrounds that pocket of magma, so right around in here, that's where you're going to find that metamorphic type rock. There's little to no pressure involved in this type, it's all heat. The identifying characteristics you're looking for is that foliation, which is the mineral alignment. The minerals in the rock are layered, which facilitates breakage along flat planes. Then banding, which is alternating layers of different colored minerals. And these bands are usually distorted somehow from the heat and pressure. Don't get that confused with the stratification of our sedimentary layers. So you can see here the foliation, they look like little scratches in the mineral. And then foliation between slate and phyllite here, you can see them. This is a really good example of the banding and distortion that we're looking at in this gneiss rock, and it is a nice rock. You can see the layers are warped. They're not straight and smooth, flat layers. So if this was sedimentary type rock, you would see the black and white straight lines. But it's metamorphic because you can actually see that the lines are warped. And then here's another example of that gneiss rock. Nice example. And then metamorphic mountains formed from regional metamorphism. What you're looking at here, that is a road. This is a mountain. And you can see the different colors, that metamorphic change that occurred. So we're talking large scale. So regional metamorphism is large. There's another example of Alaska's Copper Mountain. That is contact metamorphism. So there was a magma pocket in there that caused some change in the surrounding rocks. The ID key for metamorphic rocks, you're looking for foliation, which is mineral alignment. Look for those scratches or lines of minerals in the rocks. And then banding, layers of different colored rocks, not to be confused with those sedimentary layers. And these are going to be obviously different parent rock layers. So let's sum things up. There are three classifications of rocks. There's igneous, there's sedimentary, and there's metamorphic. Those igneous rocks are formed by the cooling of magma, which is melted rock. Sedimentary is formed by compaction and cementation of rock fragments or evaporated seawater or compacted remains of plants or animals, fossils. And then finally there's metamorphic type rocks, which is formed by heat and pressure or just heat. And it can change existing rocks into different rocks. But remember, if it melts, it's no longer metamorphic, it becomes igneous again. Those ID keys that you're looking for. So when you're given a rock and you're asked to identify what is this type of rock, well, you have your reference sheet to use, but you have to know which one of those sheets to use. So you need to be able to identify, is it igneous? Does it have crystals? Does it have gas pockets? Then it's an igneous, and then you would go from there. Sedimentary, obviously if it has fossils, that's a pretty easy one. If there's layering, if there's fragments within the rock, then it's going to be sedimentary. And finally, metamorphic, you're going to see foliation or lined up minerals. It's a little bit harder to see distinction with metamorphic rocks. So with sedimentary, you can see the fossils, you can see the big chunks of rocks. Igneous, you're going to see the crystals, you'll see the gas pockets. Metamorphic, if it's just pretty smooth and boring, it's probably metamorphic.